As its name says, an inverse function reverses another function. Here we have a way to represent a function and an inverse function. As you know, a function is a function if the values of x are not repeated. And an inverse function only changes the y-axis values into the x-axis values. As we can see here, the A, the B, and the C on the inverse function are on the y-axis, and the 1, 2, and 3 are on the x-axis. It's more complicated than that, but if you want to just represent it like this, you just have to change these values into the x-axis values. Moving on to actually solve an inverse function, we have here a function, normal function. This function is 5x minus 4 divided by 2x plus 7. To get the domain, we have to only focus on the denominator, 2x plus 7. We have to put it equal to 0, but actually, since it's a rational, it's going to be not equal to 0. For example, 2x plus 7 is not equal to 0. Then you just have to isolate x, and on the result, we have that is minus 7 divided by 2. The domain of the function is going to be all real numbers minus the minus 7 divided by 2. And the range and the inverse range of the function, it's going to be exactly the same as the domain of the function. Then we need to change the values of x with the values of y. For example, here we have that x equals 5y minus 4 divided by 2y plus 7. We only change the values of x into y values. Then we have to pass the 2y plus 7 multiplying with the x, since it was on division and is the exact opposite. You have to do the exact opposite. So you're going to have 2y plus 7 multiplied by x equals to 5y, and then minus 4. Then you just have to solve it, and at the result, you're going to have y equals to 7 minus 7x minus 4 divided by 2x minus 5. There you have your inverse function. And to get the domain, you just have to classify the function exactly the same, and since it is a rational, you have to only focus on the denominator, which is 2x minus 5, and then you just have to isolate the x. And at the end, you're going to have x is not equal to 5 divided by 2. It's not so difficult, and you just have to be so careful when you multiply, divide, and with the signs. To verify if your inverse functions are correct, you must use the double condition. The answers of this operation must be always x. You have two functions, the normal function that you use at first and your inverse function. You have to use, the exact same process that you use on composite functions, and you have to put the structure of your first function, which is f, and then you have to include your inverse function. this is your structure, or 5x minus 4 divided by 2x plus 7, and then you're just going to, the x values, you're going to replace it with this. At the end, you're going to have 5 multiplied by minus 7x minus 4 divided by 2x minus 5. But remember that you're missing your minus 4 and your plus 7. You're going to put it after the parenthesis is going to be minus 4 divided by 1. You have to do all the operations, and once you multiply it, you're going to have it like this, like the second thing here. But you have to, well, subtract by the minus 4, and then you have to add the plus 7. Remember that on the additions and subtractions of fractions, you have to put all the denominators, but since there are 2 denominators, and since one of them is 1, you just have to put 2x minus 5, and then you divide the 2x minus 5 into the 2x minus 5, and then you multiply it by the numerator. It's going to be the exact same process on the below part of the fraction, and then you just do tortilla rule, and you're going to have something like this, which eliminates with the minus 43 into the minus 43, and then you have x. You do the exact same thing on the other with your inverse function. You use the structure of the inverse function, and then you replace it with your normal function. At the end, you're going to have 43x divided by 43. You eliminate it, and you're going to have x.